All right, so lesson 3, unit 4, lesson 3. The title is particle motion, and really, don't ask what a particle is. A particle is just can be anything. It can be a bug, it can be a car, it can be a person moving. So this particular lesson is just going to reinforce the things that we've talked about in lesson 1 and lesson 2. So unit 4. Lesson 3, we're going to start with an example or a function. I'm going to write it up here. S of t equals t squared minus 4t plus 3. Okay, so what this says is that a particle moves along a line so that its position at any time t greater than or equal to 0 is given by S of t equals t squared minus 4t plus 3. Where S is measured in meters and T is measured in seconds. Okay, so it says, the very first thing says, find the displacement of the particle during the first 2 seconds. Okay, so do you recall what we said about displacement? Displacement is the distance between your starting point and your ending point. So how do we calculate that? Well, displacement is simply change in position. The change in position. And change in position, our position function is S of t. And since we want the first 2 seconds, then I will, all we have to do is calculate S of 2 minus S of 0. So S of 2 equals 2 squared minus 4 times 2 plus 3. And that turns out to be 4 minus 8 plus 3. 4 minus 8 is negative 4 plus 3 is negative 1. Okay, so that's S of 2. So that would be negative 1. And by the way, what that means is that this particle, let's say the line is horizontal. Let's say this particle or bug, let's say we have this line. Let's say the bug starts here. So at t equals 0, the bug starts walking. And at some point it turns around and comes back and just keeps walking along this line. So what S of 2 says is that at 2 seconds, the bug's position is at negative 1. So here's where the bug is at time 2 seconds. Okay, so now let's talk about S of 0. S of 0 is going to be 0 squared minus 4 times 0 plus 3. And this will clean up to be 3. So if this is, let's say, an origin or a point of focus, at time at time 0, the particle is at position 3. So the bug or the particle or whatever at time t equals 0 starts at 3 and moves back and forward. And the 0 here, I don't want you to think that's time. Negative 1 is a position, 3 is a position. This mark right here simply is a point of origin. Let's say that it's just a point of origin, some sort of focus point. So let's go ahead and get back to this. So this displacement is negative 1 minus the bug or particle's position at S of 0, which is negative 3, and that turns out to be negative 4. So what does that tell us? That tells us that the particle is 4 meters left of the origin. And I think I've said here left of its original position. I think on our notes I said original position, but that's really, that should say left of the origin. Okay. All right, then the next thing to the right, the next question to the right of that says find the average velocity of the particle during the first 4 seconds. Well, now remember, average velocity is a change in position divided by the change in time. So what will that look like? Well, since we want to know the average velocity during the first 4 seconds, then this formula, or I would find this by s of 4 minus s of 0 divided by 4 minus 0. So average velocity is the change in position divided by the change in time. And our position function is our s function. So you can do the work. S of 4 is actually 3. S of 0, we found that to be 3. And divide that by 4, and we actually get 0 over 4. So what does that tell us? During the first 4 seconds, the average velocity of the particle is 0 meters per second. Well, how can the average be 0 meters per second? Well, that just means that the velocity in the positive direction and the velocity in the negative direction were the same values but had opposite signs, so they canceled each other out. Okay? Now the next question says, what is the instantaneous velocity when t equals 4? So instantaneous velocity, remember we said instantaneous velocity is v of t, which is the derivative of position, so, or s prime of t. So looking at let's see if I can squeeze, yep, there we go. So looking at the position function, the derivative then will be 2t minus 4. And this particular question wants us to find the velocity at t equals 4. So all I have to do now is substitute 4 for time. So 2 times 4 minus 4. 2 times 4 is 8, minus 4 is 4. So the velocity of the particle at 4 seconds is 4 meters per second. So the particle at t equals 4, the particle is moving at a rate of 4 meters per second. Okay. Okay, then the next question, very similar, but this time the question is, what is the acceleration of the particle at t equals 4? So now we want to talk about acceleration. Okay, so very similar. Remember what we said about acceleration. A of t is the first derivative of velocity. So A of t is v prime of t. Well, remember this is v prime. And what then is the derivative of 2t minus 4? It is simply 2. So the question was, find the acceleration of the particle when t equals 4. Well, at t equals 4, the acceleration of the particle is, kind of ran those together, 2, what are the units? Meters per second, or meters per second squared. So at t equals 4, the acceleration of the particle is, basically the particle is accelerating at 2 meters per second squared. Now, we could also say that for any time, for the length of time that the particle is moving, the particle is accelerating at 2 meters per second squared, because again, A of t turned out to be 2, and that would be the acceleration for any time. Okay, so now the next part to this question, I'm going to get a new piece of paper. And I'm going to put all three functions back on the page. S of t equals t squared minus 4t plus 3. V of t we found to be 2t minus 4. And A of t we found to be 2. So now what I want us to do is I want us to take some time frames, and I want us to describe the motion of the particle and also identify when the particle perhaps changes directions. So our first interval of time is from 0 to 2. Okay, so I want to talk about a tool that is going to be helpful. And we've talked about this before, and that is a little sign chart. So if I want to know anything about the velocity and the direction of the particle's motion, I get that from the velocity. So the velocity I need to set equal to 0, which would be 2t minus 4 equals 0, and t equals 2. When I create my sign chart, I only have one critical value, and that's 2. This velocity is linear, which would be a linear function that's rising. So I know that my sign chart is going to be negative, positive. So I also want to perhaps go ahead and find some information about acceleration. Acceleration, let's talk about where the acceleration equals 0. Well, acceleration does not have any critical values. Acceleration does not equal 0. What we do know is that A of t equals 2 for everything. So I'm not even going to put some numbers on here. This is simply A of t equals 2, which means in terms of positive or negative, the acceleration is always positive. Okay? Okay, so now let's talk about, remember that velocity is like the first derivative and acceleration is the second derivative. So I like to create a double sign chart. And that double sign chart looks like this. I only have one critical value that I need on my sign chart, and that is 2. I'm going to talk about what was the velocity from 0 to 2 was negative. The velocity from 2 to whatever is positive. Now let's add the acceleration on there. Now the acceleration for all time values is positive. So I actually like to put that on both of those pieces of information on one sign chart. And what that allows me to do, I'm so sorry, let me scoot that up a little bit. So what I've done is these two are my individual sign charts. Now I've created a sign chart where both pieces of information are all on one sign chart. So now I'm going to go back and I want to talk about from 0 to 2. I want to describe the motion of this particle and speed of the particle. Okay, because the velocity is negative, this particle is moving to the left. Because acceleration, or since acceleration is positive, then that means the particle is slowing down. So, particle is moving left because V of t is less than 0 and slowing down because A of t is greater than 0. Okay, so when velocity and acceleration have opposite signs, the particle will be slowing down. Okay, then at t equals 0, let's talk about t equals 0. So at t equals 0, the particle stops because V of t equals 0. Let me think about that for a second. That's not correct. Let me come back to that. I think I've included something that's not correct there. But let's talk about for the values that are greater than 2. I don't think I need that one on there. That one's getting a little advanced. We don't need to talk about that one. But let's talk about for the values of 2. Oh, I know what it is. You know what? That was supposed to be, and I've got it wrong on your piece of paper, but what about t equals 2? Well, at t equals 2, the particle has stopped. The particle stops because V of t equals 0. That's what that was supposed to mean. I'm sorry about that. So make sure on your notes that you've put that as t equals 2, not t equals 0. But now let's talk about for t greater than 0. For the times that are greater than 0, the particle is moving to the right because velocity is positive, and it's speeding up because acceleration is also positive. So particle moves right and speeding up because V of t, is greater than 0 and A of t is also greater than 0. So the particle speeds up when velocity and acceleration have the same signs. And so this right here is just an organizational piece that allows me to kind of compare and look at velocity and acceleration on the same time intervals. Okay, so looking at the next examples, I think I'm going to leave the next couple of examples to you. But here's what I do want to, remind you of. I'm going to summarize a couple of things, okay? When V of t, let me rephrase that. And I may have included that on lesson 1's notes, but an object speeds up when velocity is greater than 0 and acceleration is greater than 0. An object will also speed up when velocity is less than 0 and acceleration is less than 0. So velocity and acceleration have to have the same same signs. Pardon me. An object will slow down when velocity and acceleration have opposite signs. So when v of t is less than 0 and a of t is greater than 0. Or when v of t is greater than 0 and a of t is less than 0. Those are the scenarios when an object or a particle or something that is in motion speeds up or slows down. So I'm going to let you kind of look through your notes for the sake of time. And as always, guys, if you have any questions, please don't hesitate to reach out to me. So that's all for lesson 3. We will do lesson 4 next.